Alright, today we're going to talk about work. We've used this word quite a bit. It has a similar meaning in physics, but it's more mathematical, I would say. But ultimately, learning about work and the next thing to come, power, is going to help us calculate the amount of electricity it's going to cost to run our roller coasters. So, what is work? According to physics, work is a force applied over a distance. Alright? You should have hopefully kind of recognized this from something before. And as we continue to talk about it, hopefully you'll recognize more about this. But work's equation comes from those two things. There's a force applied over a distance. So it's the force needed, or the force applied, times the distance it's applied for. Or work equals FD. Alright? You can also write that as work equals FD without the little multiplication dot in the middle. Okay? And similarly, the units for force are newtons, the units for distance are meters. So units for work are newton meters, which we've seen before. A newton meter is also known as a joule. So hopefully you're kind of recognizing, hey, this is the same as energy, and kind of specifically potential energy. So eventually we will discuss that relationship in class, but work and potential energy are really closely related to each other. So one thing that's going to help with work when we deal with it in the vertical direction. So work in vertical direction, the force is going to be the weight. All right, so the force of gravity or weight of an object. So just keep in mind, those mean the same thing, force of gravity or weight. Don't let that continue tripping you up if you've been that person who's kind of gotten that confused with mass and things like that. Force of gravity or weight is calculated by taking the mass of the object and multiplying by gravity, or 10 meters per second squared. Okay? And weight, its units in the metric system, which is the only system we use in physics class, is in newtons. So a 46 kilogram object, if we want to lift that up into the air, we have to overcome its force of gravity and apply 46 times 10, or 460 newtons, to get that object up off the ground. Okay? So, work, very, very simple equation. So I'm just going to do a couple of sample problems to give you the idea, but hopefully this is a very easy topic for you to comprehend. So we have a 20 kilogram object that has moved a distance of 5 meters by a net force of 50 newtons. What is the work done? So our knowns, and what do we want to know? Well, I'm writing everything that I see. I have a mass of 20 kilograms. I have a distance of 5 meters, so D, and a force of 50 newtons. And what I want to know is work. So, equation is work equals force times distance. In this case, we are moving horizontally, which means the mass is absolutely irrelevant. We just don't need it. Okay? So, the other knowns exactly match what we do need. So, work is equal to 50 times 5, or 250. You could write joules like you're used to, or you can write newton meters. Either works, but not both. It's either or. Okay? So, another sample problem. If a machine does 500 joules of work in order to move an object 25 meters, how much force does it apply? So, our knowns. We know that work is equal to 500 joules. We know that the distance is 25 meters. And then what it's asking for is force. Alright? Our equation is work equals force times distance. But we want to find force. So how are we going to move that distance? We're going to divide both sides by D. So force is equal to work divided by distance. Okay? So if we substitute in for that, we'll have force is equal to 500 divided by 25, which gives you 20. And what are the units for force? Hopefully you are saying newtons. Alright, last sample. If it takes 650 joules of work to apply 100 Newton force to an object, how far does the object move? So our knowns, we have work is 650 joules. We have force equal to 100 newtons. And we have distance being our question mark. So our equation is work equals force times distance, but this time we want to solve for d, so we have to move the f. So we divide by f on both sides. The f's on the right cancel out, so we'll have distance is equal to work over force. Then you substitute your knowns. That's going to be 650 divided by 100. So our distance is going to be 6.5, and units for distance are, hopefully you said meters. So make sure you have notes for class tomorrow, and make sure that you do the online form, and I will see you in class.